Hello, my name is Atif Ali and this is my BBE 2201 dorm energy audit. In this project, I aim to conduct an energy audit on my dorm room at the University of Minnesota by measuring the electricity use of many appliances found in my room. Using this information, I hope to be able to compare my electricity use to the national averages. For this project, I measured my energy usage in my dorm room at Middlebrook. Currently, my roommate and I live in the dorm, and as far as appliances go, we generally limit ourselves to a fairly small amount. I was able to measure every electrical appliance in my room, barring my electric toothbrush charger, video game consoles just because they're so rarely used, and my roommate's laptop and phone charger. The washing machine that you'll see later on in this presentation that I collected data from was from my house in Coon Rapids, Minnesota, because I was not able to gather data from the washer and dryer units at my res hall. I tried to collect data from a mix of the smaller and larger appliances that I use on a fairly regular basis. Note that I could not measure my dryer because the plug was not compatible with my kilowatt meter that I took measurements with. Here's some data about Middlebrook that I obtained from facilities management at the U. Notice how the total energy demand is about 10 to 13 BTUs per hour times square feet, which is about 0.00293 to 0.00381 kilowatts per square feet. Notice how this is roughly double to triple what the average Minnesota home uses per square foot, which shows just how much more energy per square foot a residence hall needs, and perhaps how inefficient they can be at energy usage. This, however, does include energy usage for things like having a large dining hall, many washers and dryers, and the other additions that a residence hall needs compared to a typical Minnesota house. The graphics below show other interesting statistics like steam usage in pounds per hour, energy costs and emissions, and the second graph shows how Middlebrook's electricity use fluctuates throughout the day. As you can see, there's a small amount at night and higher amounts of use during the day. Here you can see a table obtained from the Energy Information Administration on how energy use is split in the residential sector in the United States. I found this interesting to compare to my own usage, as by living in a dorm I don't directly use energy on things like cooking, controlling space heating and cooling, lighting, or washing dishes. However, by using services like the dining hall and using the provided utilities, I indirectly contribute to how those energy sources are used in my residence hall. I took my electricity usage measurements using a kilowatt meter that I purchased online. For constant power appliances, which include my microwave, lamp, desk fan, and television, I plugged the appliance into my kilowatt meter and used it for a typical amount of time depending on the appliance. For the washing machine, this would be something like 3 loads of laundry. For the TV, this is a couple of hours. For the microwave, this is microwaving something for, say, 1 or 2 minutes. And for the lamp and desk fan, it was leaving it on for a couple of hours. I then read the kilowatt hour readings directly off of my meter and took into account how many hours the device is used in a month to find my monthly energy usage. For the variable power options, like my mini fridge, laptop, and phone charger and air freshener, I left the device plugged in for an extended period of time, which is usually a pretty high amount of hours, and acquired the kilowatt hours directly from the meter, and again accounted for how much time these appliances would be on over the period of a month. I compiled the results of my energy collection in this table and found my daily energy usage from these appliances to be about 1.15 kilowatt hours per day, and then I found the monthly energy usage to be about 34.5 kilowatt hours per month by multiplying by my daily use by 30, and then I found my yearly usage to be about 420 kilowatt hours per year, which was found by multiplying my daily use by 365. Some of my methods for collecting data differed between appliances. For my washing machine, I put in 3 loads of laundry, and since each load takes about 45 minutes, I took my total kilowatt hours for the duration, which was 0.33 in 3 loads, and divided that by 3 loads to get 0.11 kilowatt hours per load. And since I do about 2 loads of laundry per week on average, I used 0.22 kilowatt hours in 1.5 hours per week, which is about 0.03 kilowatt hours per day. For the TV, although I measured it for roughly 75 hours, it was only in use for about 5 hours of that. That is pretty typical of a week for me, because the only time it really gets turned on is with gaming with friends on the weekends. This energy usage table does not take into account the average 2 loads of laundry that I dry every week, my toothbrush charger, which probably would have minimal impact anyway, and my roommate's laptop charger and phone charger. I listed out some comparisons of the appliances that I measured versus standard energy usages for the same appliances. My washing machine appears to be much more efficient than the average washer, as it uses about 1/20th of the energy that the average washer uses. Everything else is fairly typical and standard. This is probably because most of the appliances that I use are fairly new and up to date. The one exception that I could not find data for was mini fridges, So I used a measurement for a 14 cubic foot fridge. To compare, my mini fridge is about 6 cubic feet. Here are some pictures of me having fun taking measurements. This project helped give me an idea of how my electricity use relates to the larger picture. I found that as an individual, I use very little electricity in my living situation, as I use about 420 kilowatt hours in most of my appliances per year, whereas the average household in the US uses about 11,000 kilowatt hours. Obviously, the measurements I took did not include heating and cooling in my living situation, as those data were not accessible to me. Hopefully, as I continue throughout life, I will be able to use this knowledge of energy to use less energy overall.